Okay, so let's get started. My name is Mark Pulowski, and I work with WebAge Solutions, doing trainings and consulting. Um, and what we're going to go over today is Kubernetes patterns. Okay, there's a lot of different patterns, uh, so there's a handful that we'll be able to go over. Okay, let me take a look at the overview. This is what we're going to be covering today. We're going to have this presentation first. Kubernetes related issues and their pattern solutions. When we're done with that, that should be about 25, 30 minutes. Then we're going to do a live demonstration of putting together a small example application with a sidecar pattern. Okay. And those two items will be the bulk of the presentation today. After that, we'll do just go through a couple of good books on Kubernetes that might be helpful to you guys. You may already know about them or not. We'll talk about WebAge, and we'll have some time for Q&A hopefully at the end. Okay, so let's see here. So we're at the presentation. Let me bring that up. Now these two presentations, that overview that I was just showing you before, and this one here will be available. I've also put them in the handout section of GoToWebinar. So if you're interested in looking at them now, you could download them from there. They're PDF files. Otherwise, they'll also be available after. They'll be sent after the presentation to you. Okay, so we're going to start off with kind of like an overview. Just a couple slides to get us oriented. The first one is about containers and their management, right? So we're talking about Kubernetes, so we need to talk about containers. Containers are execution environments where you bundle everything that's needed to execute an application into an image. Okay, you take that image and you run that image. Okay, that's what you do with Docker. You create an image, you run the image, and when you run it, you get something called a container. Okay, now Docker is great if you just need to put up an individual image, but there's often other things you need. Okay, if you're not just doing this for development, if you're doing it for production, for example, you may need to run multiple instances of an image. You may need to route requests to multiple images, right? So you're scaling out the application so it can handle more traffic, right? You need to provide network access to the images, make sure that they're secure, but that somebody from outside this cluster that's being created, cluster of images or cluster of containers, can access that. Okay, so this is just a small list of additional capabilities that are helpful, and that's where Kubernetes comes into play. Kubernetes is a platform that allows you to run an individual image if you want to, but it's made for you to scale from there to run as many images as you need um, so that your application is usable by everybody who needs to use it. Kubernetes, if you're here, you probably know about this. It's a container management system. It started off in Google. Okay, Google needs to run a lot of the same application to do things like crawling websites and handling search engine requests and things like that. So their data centers was where Kubernetes started off. I think it started off with the name Borg, and they changed that when they put it to open source. Kubernetes is Greek for pilot or helmsman. So you can see they were thinking about Kubernetes' role in running applications is kind of being in charge of all the different instances. And the last part of this overview is just going to be talking about design patterns. Now, patterns are repeatable solutions to common problems. If you actually research it a little bit, they're a little bit more specific than that, but that's basically what we're looking at. They're real solutions that can be used or that have been used and solved certain problems. So we're going to be talking about patterns specifically related to the Kubernetes platform. And when it comes to that, I've separated them out into three different, what I'm calling levels, right? So Kubernetes itself, when it's built, when it was put together, has certain features that are based on patterns. And we'll take a look at some of those patterns. We'll also take a look at some Kubernetes extensions. We'll talk about how they employ patterns. Okay, so when you have Kubernetes, there's a certain amount of functionality built into it, and then there are third-party applications that you can use to extend that. Okay. We'll talk about that, and then lastly, we'll talk about how you can employ patterns in your own applications. So if you decide that you want to make your application more robust, or you want to add certain types of features, it makes sense to look into whether there are patterns around those features that you're looking to add. Okay. So the first set we're looking at is the Kubernetes pattern-based features. Okay, and there's two features that I've pulled out here. One is the feature of Kubernetes where you can schedule applications to pods, or where that's what Kubernetes does. And to do that, it follows two patterns. Okay, it may follow more if you actually go deeper into the code, but from a high level, these two patterns are certainly in use. One is called the predictable demands pattern, okay, and the other one's called the automated scheduling pattern. Okay, we'll go over this in one of the upcoming slides. The other feature I wanted to mention was maintaining viable instances. Okay, so Kubernetes, one of the things it does is load balancing. And to do that, it needs to know whether an instance is actually alive or not. Can it respond to requests? Okay, so how does it do that? It follows the health probe pattern. Okay, and the health probe pattern we'll talk about in more detail, but it basically allows the application itself to respond to certain probes if it's alive, and if those probes no longer get a response, then it makes the assumption that the application is not running and needs to start up a new instance of it to replace that instance. Okay, so let's take a look at the first one, the scheduling application to pods. Okay, that uses this one here, or this is one of the two that I mentioned, predictable demands pattern. Okay, so there's a lot of text here. I'm going to try to summarize it a little bit. Okay, so we'll start with the solution, and then we'll go and look at some of the other things that are mentioned here, the theme, the problem, and the implementation. Okay, so the solution, and then we'll work back from there. All application requirements that include resources and runtime dependencies should be determined and declared in advance. Okay, so when you're running your application, especially when you're developing your application, you don't really know how much resources your application is going to take. That's something that you find out when you test your application and you watch how it behaves. Okay. Now, if you never did that, then when you go to put your application into production, okay, you're then throwing your application into a system where you don't know how much um, memory it needs, how much CPU it needs to run an instance, right? So that's the solution actually is pointing to what the problem is, right? That you need to find out that information about your application, okay? And if you do have that, then you're going to be able to effectively schedule applications. So from that, we go to the theme, obtaining the right amount of resources allows you to effectively schedule applications. Okay, scheduling applications in Kubernetes is the process of where Kubernetes looks at all of the resources it has, which means all of the nodes, all of the memory on the nodes, all the CPU slices of CPU that are available, and it decides which node it's going to place an application or an instance of an application on. Okay. So if you know ahead of time and you can tell it, I expect this instance to need this much memory and this much CPU, then Kubernetes can effectively schedule it or find a place for it. Okay. So why would you want to do this? Now, there's a couple of ways you could handle this situation if you didn't have this information, right? You could just buy more resources than you need and then just, run something on its own machine, okay? And this is kind of wasteful. You're spending too much money and you're managing too much resources, okay? So you want to use your resources efficiently, okay? And if you're not scheduling things or you're not letting Kubernetes schedule them, then um, there's room to optimize, okay? Now, if you don't buy more resources than you need, then you always have problems with the applications running. You don't know whether they're going to run effectively or not, and whether they're going to be able to handle the amount of traffic that's coming into them. Okay. So all of this, the predictable demands pattern, is built into Kubernetes, where Kubernetes lets you declare when you create your deployment how much resources you need. Okay, so that's what the implementation would be. We won't go into the actual implementation because we're going to concentrate on patterns here. Okay, so we'll get on to the next pattern, the automated scheduling pattern. So these go hand in hand. One, you need to have the amount of resources available, okay, so that you can tell Kubernetes, and then Kubernetes can use that information to schedule your um, your applications into the resources that are available. Now, the thing about this is that we're talking about automated scheduling, okay, which means if you have that information, you can give it to Kubernetes and Kubernetes can run a process where it will automatically schedule something, okay? Because it's also possible for you to manually schedule things, right? You could just have somebody say, okay, we need to bring up these 5 instances, calculate how much resources you're going to need, and then we'll take a look. We'll actually look on the different servers and see which one's available, right? That would be a manual scheduling pattern, right? But the scheduling pattern that the Kubernetes scheduler uses, it's automated, and it uses the information that was collected from the first pattern that we mentioned. Okay. Now, one thing I want to mention here, just about patterns in general, it will, at the end of the presentation, we'll be mentioning a book. It's a very good book on patterns, and they go into a lot of these things in a lot of details. Okay. More than we can do in just an hour. Okay. So if this does pique your interest, know that we'll have that book title available for you to take a look at. Okay. Now, another pattern that's used by Kubernetes as opposed to by Kubernetes extensions and opposed to you writing your own application is the health probe pattern. Okay. Again, we'll look down to the solution. So a system that requires knowledge of an instance's health. So what would that system be? That system is usually the load balancer. The load balancer takes requests and then hands those requests off to different instances that are running, okay, or that it thinks are running. If it starts sending a dead instance, one that can't respond, there's something wrong, it's locked up or something like that. If it starts handing requests to that, those requests can get lost. Okay, one, they won't get responded to because the actual instance is not working. And two, then you'll need to have some kind of fail-safe so that the application will retry that and maybe get a live instance. Okay, so it's very important that the load balancer be able to tell how, whether a specific instance can handle requests or not. Okay, and part of this pattern is based on the fact that, if we knew that the application was fail-safe, that it never went down, we never had instances that went down, it would be easy. You wouldn't need this, right? But we kind of admit to the fact that there are problems with applications that we can't tell ahead of time, that instances will go down, okay? It's just a fact of life, and that's why this pattern was developed, okay? So what the pattern does in the implementation is it lets you, as an application deployer, somebody who's deploying the application, um, set up some responses that your application can give if your application um, is alive, okay? And there's a couple of different levels if you actually look into um, how health probes are used in Kubernetes. You have a health probe that just checks to see if the process is running. You have one to see if the application has started. You have one to see if the application is ready to send responses to requests, okay? So it's actually a multi-level checking of an instance to make sure that um, the you can get through, right? Okay, and again, this is one of those things that we'd spend a half hour just talking about health probes, right? But the point here is that there's a pattern um, that takes care of this problem, which is the fact that instances may be dead, and you may need to find out which ones are dead and to switch over to ones that are not. Okay. Now, there are also patterns that are used by extensions to Kubernetes. Okay. One of the extensions that a lot of folks use is logging systems. Okay. Now, Kubernetes has a limited capability of doing logging. It can take the logs from your applications and save them to files. Okay. But at that point, you know, it maintains those logs, but it doesn't move them outside of the system, okay? It's very popular these days to have logging systems, like a centralized logging server, okay? And you take your logs from your different servers out there. Just say you have, 100 different servers that are running your organization. Each one of those servers can send its logs to this centralized server, and the centralized server is basically just a place for you to go and check the logs. Okay? Um, and to do that with Kubernetes, you need to add on an extension system. Usually, like the ELK logging system it uses a couple of different um, very specific add-on pieces to Kubernetes in order to um, ship the logs and use the logs, right? Um, but when we're doing that, there's a choice that has to be made of whether you have to add that information into the application itself. Should the application itself ship its logs out to this logging system, or should it be done in another way? And the way that's being used in most of these is by using the sidecar pattern. Okay? Sidecar pattern is where you have your application running in one container inside of a pod, in another container inside of the pod, which is where you can run a separate application. That's called the sidecar, because it's being used along with the application. Okay, and the sidecar is going to be used to just find out when a log is changed and then ship the changes in the log out to the log server. Okay, so that's the pattern that's being used there. Okay, and I just want to jump back a second because we have a question that came up um, in the GoToWebinar interface. Yes, it's possible to set up your applications. This has to do with health checks that we talked about previously. It's possible to set up your applications without specific health checks. If you do that, then there's it doesn't remove the possibility of Kubernetes responding to dead instances, but it gives it's very less precise, because it can only tell, for example, if the process is running or not. When you try to run a process inside of a pod, um, it can tell if that's failed or not, because that's something it can tell from the operating system, right? But if you, for example, you might have something where the application is running, but it's not running well enough, or it's not healthy enough to serve requests. Okay, so that's when you need to have your health checks in place. Okay, if there's going to be a possibility that your application can be in the middle of two different states, where the regular features of Kubernetes cannot detect that it's down, okay, then you need this enhanced ability to check to see whether the application is running and can handle the requests. Um, so yes, if you just put up your applications and you don't write your health checks into them, and on the Kubernetes site there's information on how to do that, then you run the risk of having instances be down and having the load balancer not know about it. Okay, and when you first start running your application, you might not see any of that happening. Maybe when it's more loaded, there's more load on the system, you start seeing that more often, right? Where you're sending requests to dead instances. Okay, so just wanted to cover that. Yeah, now we'll go down the other pattern here that we want to take a look at. Has to do with another extension, a popular extension to Kubernetes, which is a network communication services. And in fact, those services are typically go by the name of the pattern that's used to provide them, called the service mesh pattern. Okay, the service mesh pattern actually uses a sidecar as well. Okay, but the pattern, um, it more than just has a sidecar, there's specific things that it does, and we have some diagrams that we'll take a look at to show you how these work. Okay, so let's go down and take a look. Here's a just general diagram to show a logging system. You start off over here on the left with the Microservices app. Let's assume that's the type of application that you're running. And you're running it in a pod. Okay, in that pod, you're also going to run a logging agent. Okay, so it's a separate container within the same pod. Okay, everything that's in a pod gets scheduled onto the same node. Okay, so it's not going to split up the pod into two different nodes. And a node is a computing device, right? So this means that both of these applications are going to be running on the same computing device. Therefore, they're going to have access to the file system. Of course, to do that, you need to make sure that you set up your volumes, your Kubernetes volumes, so that they're both pointing to that volume. Okay, the microservices app needs to point to the file system volume in order to save the log. The logging agent needs to point to the that same location, the same directory, okay, in order for it to read the log and send it over to the centralized log server. So this would be a log server like Splunk or something like that. Okay. And the next one, here's a service mesh diagram. Service meshes can get conceptually complex. So it's good if we talk about some specific things. Each one of these little boxes here represents a pod, okay, that has a service, some kind of application you're running, and a sidecar in it. This sidecar that's running is running the service mesh agent, okay? Whatever the service mesh, the company that makes it is calling that agent, that's what's going into this sidecar. So not only do we have these two main ones that we see here, but these other ones represent other applications that might be running on your system, okay? And when you bring up a service, that service may need to talk to another service to satisfy a request, okay? Or it may need to talk to a background server that's running as a service, okay? So what you don't see here, what's a little bit hard to see, is that the services, once you set it up with the service mesh, the services all talk directly to the sidecar. Their networking talks to the sidecar and takes network requests directly from the sidecar container. Okay, but they no longer um, take requests from the general network, right? That's what the sidecar is there for. The sidecar in a service mesh is the one that is accessible over the network and can see the other sidecars. Okay, so sidecar is kind of like an assistant now, a networking assistant, where think about an office where you have somebody who is acting as the administrative assistant or the secretary, and you have to see them in order to see the person in charge. That's kind of what's happening with a sidecar that's being used for service mesh. Okay, all networking, phone calls, things like that, come through the sidecar. And just for you who are not so familiar with the service mesh, these are some of the things that can take care of then. Observability, so making your application easier to observe, controlling your application, making connections to it, and providing security. That's all now going to be um, uh, charged as a thing that the sidecar application will do. Okay? And there's a couple of different service meshes that are popular. They all do this. They all bring up these sidecars, and the sidecars are the ones that talk. Okay, and the services only talk to their personal sidecar. Okay, so let's take a look at some application level patterns. This is what I'm calling the the patterns that you might use when you're writing your own applications. Okay, so the ones that we talked about so far are the ones that are in Kubernetes: scheduling, health check, ones that are used by external applications. Okay, sidecar pattern, things like that. Um, and now we'll talk about three different things that you can do in your own application. Um, and one of them we'll take a look at an example. Okay, because that's what I want to get to, is that example. And that's going to be of this, the accessible logs. Okay, so you can create a system where you set up a web server that lets somebody access the logs directly from the web server. It might be something like a backdoor that you're using for the developers during development, something like that. Another application level feature that you might want to implement is a startup check. Okay, you might want to set up your application so that the startup code, the code that does things like checks to see if there's a place to put the logs, it checks to see if there is a server, like a database server that your application needs to run. Check to see if networking is working. Sometimes you have all these checks, and they kind of they kind of mess up your application. It's a lot of code to do those things. You can move those into something called the init container. Okay? So the init container pattern would be used to separate out startup check code from your application code. That lets your application code be more clean, okay, and has all these, these checking type activities in the init container. And then data backup. You may have an application that doesn't talk to a database, but it does have some configuration or other types of information that changes over time that you would want to back up. And in order to back that up, you might have a backup system. Like we were talking about an external logging system, you might have an external backup system that accepts data in a certain format, like it accepts a bunch of JSON files in a zip format or something like that. You can use the adapter pattern, okay, to create that data backup, okay. And so the adapter pattern, again, is going to run in a separate container from your application. Your application doesn't even have to know that the data backup is happening, okay? But it's going to be handled by that other um, application running in its own container, okay? And let's see. So this is the first one, the accessible logs feature. It uses the sidecar pattern, okay? And I think, do we have a, yeah, we have a picture of this one. So this is similar to the external um, logging server one, okay? You've got your application, which drops the log files. the web server, which looks at the log files and makes them available. And that's what we're going to take a look at when we jump out to a live running Kubernetes and walk through that application. And let's see. So I just want to show you that there's some information about the other ones. The application startup check tells you about the pattern that's being used. Okay, we're not going to go through these because I'm going to spend the time in the example application. Okay, so this was there was just a couple of slides there that we didn't have a lot of time for, but let's go to here and bring up an actual instance of Kubernetes. So I have Kubernetes here. It's a Minikube version or that distribution of Kubernetes, which is good for trying things out. You notice there's no pods, there's nothing running in it currently. This is the Kubernetes dashboard. So what we're going to do is we're going to take a look. I have a couple of YAML files, and these YAML files are deployment files. So we'll take a look at the deployment files, okay? And then we'll walk through this deployment and get it to the point where we've got a couple of applications running in different containers. Okay? So the first thing I want to do is just open up the first one, app-pod -01. Okay, so this is the application we're going to start with. Okay, now it's just a simple application. All it's doing is it's running this script here. It's like a Linux script. Okay, and the reason for this, we just want it to drop a log file or a new log entry every 5 seconds, so that we can see that it's dropping things into the log file. Okay, so what we can see here is it's going to be a shell command that runs, and it's going to be in a loop. It's using this while true loop. Okay, and it's going to create a date. It's going to send that date or append it to the app.log file that's in the var log directory. Okay, so that's all this application is going to do. So just imagine that you had an application that, something that you've worked with before, maybe a Java microservice or a Node microservice, and it was outputting logs. That's what this is going to be doing. It's during each loop, it's going to sleep for 5 seconds and then take another date and push it out. Okay, and it's going to do that until we stop running it. Okay, so let's actually run it. Okay, we do that with an apply command. Okay, so it created the pod, and if we take a look over here, we should see that that pod was created. Okay, and then let's see, if we take a look at the details of the pod, let's see if I can do that from here. No, I think I'm going to do it from the command line. So we're going to do, let's see, kube control, describe pods, application, pod. Okay, so the name of the pod that we've deployed is application pod. And when we describe it, Kubernetes is going to dump all its information about it. And if we just scroll up, we can see that in the containers section of this information about this application, we have an app container. Okay, that's the only one we have currently. And what it's doing is it's running this script that I showed you from the file. Okay, so now it's nice to see that, but let's, we want to be a little bit more. We want to really see what's happening in there. So what we're going to do is we're going to shell into that container. Okay, so we use the exec command to go to the application pod and specifically to the app container, okay, which was the name of the container. Okay, and we're going to run the bash shell. And you notice that it changes we're now inside of that container. And from inside that container, we want to take a look at that app log file. Okay, so ls, we're just going to list it. Var, this is where we said it was going to be, var log app.log. Okay, and we see that it exists. Okay, so the application was successful in creating it, and now it's this large, 638. And if we go and run it again, you notice it's larger. Okay, and in fact, if we tail it, which means we're going to run this tail command, var log app.log, we should see that every 5 seconds it's going to add something to the end of this. If we just wait a little bit, we see that that is adding. So it continues to add items to the log file. So it's doing what we expected. Okay, that's the setup. That's our application. It's creating log entries. Okay. So what we want to do is add on another container that's going to have a web server in it. So to do that, let's get out of here, exit. So we unshell, we're not shelled into that container any longer. And we're going to take a look at pod number, app pod 2. This is just everything up to here is the same as before. Okay, but in addition to that, in the containers section, we're going to run a second container. This container is going to be based on the Nginx image, okay, and it's going to run on container port 80. So that's all we're doing. There's going to be one step after we do this. So let's see if this is going to work, right? But to do it, we're going to we need to remove the existing deployment, okay? And that's just a technical reason. When you run these deployment files, you can't add a container to one. If it only had one container before, that's all it can ever have. So what we have to do here is we have to stop or delete the current application, and then we'll just start it up again with the new description that has both containers. So there we delete the pod. We wait for it to be deleted. Kubernetes is doing its thing. And we can watch that over here as well. Okay, as soon as it's done, this will drop off. And it should say terminating here, right? And let's just refresh that. Okay, so now it should be gone. And we can now run this new one that we have, app pod 2. Remember, all it's going to do is add that second container. And then we want to verify that it adds it successfully and starts it up successfully. So we can kube control get pods. And you notice when it starts off, out of the 2 pods, none of them are ready yet. But if I keep running this, eventually it's going to show me that there's 2 pods that are running that are ready. And we can also look at that from here. It was created, it's going through its setup. And let's see if we have, go into the application pod. Okay, let's go back here and double check. Okay, so now it shows that 2 are running. So which 2 are those? We can do describe pods, and the name is application pod. And if we scroll up, we'll verify that we can still see the app container and all its information. That's still there. But if we go down, we also see something called the sidecar container. And this sidecar container is going to be running the image from Nginx. Okay, so we'll go through and we'll verify that it's running it by shelling into it and checking out if, okay, so we're shelled into it. And at this point, we should be able to do curl, is just a command line command that does what a web browser would do. And we're going to look for localhost. And as you see, if you run down here, it says welcome to Nginx. This is actually a web page. If we look at localhost here, you'll see that it's, this one, I jumped the gun there with the port. Okay, and I'm looking at what doesn't it like here. There could be a setup issue there. Okay, well this actually, that's not inside of the container. It's not, that's the problem. We don't have a network set up. But anyway, you can see from here, okay, that the Nginx server is responding, okay? So what we need to do now is just tell the Nginx server where the data is. Where is that log file? But if we look for that log file now, ls-l var logs, I think it is, log. Okay, you notice there is no app log in the log file here because right now we're looking at the image for the Nginx server. There's a separate image for the first container. So, right, the two containers have their own images. So that's the problem. Right now, the log files are being saved not to the host system, but they're being saved to the a layer in the image of the first container. Okay, so we're going to fix that in this next iteration of what we're doing. So we're going to do nano. We'll take a look at the third iteration. Okay, and in here, we're going to start by going down to see that we've added some, where is it? Some volume here, okay? So we added this volumes. They're going to be called shared logs, and it's going to be using an empty directory on the host. Okay? Now we're going to share this between the two different containers. Here's the app container. The app container is going to mount that volume, the shared logs, and it's going to mount it to this path. Okay, so it's going to, when it saves something into this location var log, that's actually going to be saving it to this shared empty directory. Okay, the second part of this is in the sidecar container, we need to read that location. And when we read the shared log location, we're gonna actually mount that to this location. So what's this? Well, this is the location where Nginx gets its files that it serves. Okay? So if we let Nginx pull its files to serve from here, okay, after mounting the shared logs, it's actually going to be pulling it from the same directory, the shared directory. Okay? So let's just see this in action. So we will take this and we're going to delete the one that's there and just rerun it. So delete the application pod, which should delete both of those containers. Again, it takes a little while for Kubernetes to come around and do that. So we'll watch it from here. And let's go back up to pods. And it's in the terminating state, so it's doing what it's supposed to do. And it'll just be a minute until it's finished. And just to show that that's what's happening, if I go here, oh, there we go. If we do kube control, get pods, we should see that there's no pods So we want to reintroduce that application and the shared volume and the Nginx application, and they're all in this app.pod03 YAML file. Okay. So it creates that. And now how are we going to check to see if this is working? Right? Well, we know what happens with the main application. It's going to be dropping things into that log file. Okay, so what we need to do is we'll go again and shell into the sidecar container. Okay, and from here, we're going to do curl localhost, okay, to see if it has a default, a default response. And you notice here, this is interesting. Before, Nginx was sending us its index.html, its default file, but it no longer has access to that because we've redirected it. It's now looking in that var logs directory, that shared directory. Okay, so this is actually a good thing. What we want to do now is take a look here, curl localhost, and tell it we want to look for the app.log. And there it is. Okay, so here we're asking the server, the Nginx server, to provide us with that app log file, and it does. And you can see it also updates it, 5102, 5047. Okay, so whenever we want, we can just access that. Now, of course, this is an example application, and because it's an example application, we're shelling into that particular sidecar container so that we can run curl, right? In an actual application, what you would do is you'd add one more thing to it. In Kubernetes, you'd add a service to it so that you could make that server, that Nginx server, available from outside of the container, okay? And when you did that, you'd be able to bring it up in a regular web browser. Okay? So the idea here is that we now have a sidecar container. We have two containers running, the app container, the sidecar container, following that pattern, the sidecar pattern, and sharing a log file from a shared directory volume that was created in Kubernetes. Okay. So that's what we wanted to show. Just to give you an idea of, just in like 10 minutes, we were able to show you the usage of one of these patterns. So there's, it's not something to be worried about. Your usage of these patterns can be fairly simple, but because they're a pattern, it means other people have been there, they've developed that solution, and they know that it works, and then, so that's always a good place to start. Okay, so what I want to do now is go to, so we went through the example, that was the log access with the sidecar pattern, and now here are a couple of books, okay? And the links are in there for you to get to Amazon.com if that's your place where you buy books from. And so if you download or you get this presentation, you'll have that. Okay, but Kubernetes Patterns is an excellent book. It goes through a lot of these things in a lot of detail. Okay, but now that you've had a little bit of an exposure to patterns, maybe it's a little bit easier to get into this book, right? Another book that's really good is this Kubernetes Best Practices. Okay? So I would say that if you were looking in terms of experience, these are in reverse order. So the most expert one is the top one. The one for people who've used Kubernetes a little bit but want to know a little bit more. So you have some experience, you want to get some more under your belt. This second one, Kubernetes Best Practices, is good. And then for those of you who are just starting out and getting to know how Kubernetes works, the Kubernetes book is very useful for that. Okay, so those are just a couple of books that happen to be very good on the subject. Okay, so we're giving this presentation, we're WebAge Solutions, and we've got some links here if you're interested in Kubernetes training. That's what we do. Part of it you've seen in this last hour, kind of how that can work. And here's just a couple of our popular courses: Docker and Kubernetes Administrator Training, Kubernetes for Developers Training, and Advanced Kubernetes. So if you're interested in those, you could click on the links here and go ahead and take a look, or just go up to the WebAge Solutions site. And this is just some information, some other information about WebAge. This first thing is kind of interesting. You can get information on developing an application training. So this is, just say you're a team leader and you need to get some of your people up and running pretty quickly, but you need to get them up and running in not just, one application course. Maybe you need to provide a whole program for them to go through, maybe a 2-week program or something, and you want to set that up. Okay? This can give you some information about how to set things up like that. Okay? So that's the link is there if you're interested in. And this is for those of you who already know WebAge Solutions and may have gotten training vouchers at some point in the past. Training vouchers have been useful for many years. It's a way to allow employees to sign up for training without having to have a big, difficult process to do it. But they're going to stop using vouchers. So if you're in this situation where you do have a voucher, this is just to tell you, make sure you sign up for something soon so you don't lose that capability. Okay, so that brings us to our question section. If there's any other questions, I know we had to go through things fairly quickly to get everything in, but hopefully the materials, if you spend some time with them, will, the materials we went through, there's some more information in there for you. Okay, and I did want to show you one other thing here. So after the summary section in this main presentation, there's also this section, the appendix, details of discussed patterns. And in this, we go through a bunch of the patterns that we mentioned, and including one that was kind of mentioned in the marketing materials that we were going to go over, but we didn't have a chance to put together a good example of it. But the scatter-gather pattern is also one. If you've got a complex um, um, application that you want to run, that when a request comes in, it needs to make requests of multiple services and then get those requests back and package them up and things like that. That's a good pattern to use for that. Okay, so there's some other information here that we didn't go over that might be information that's useful to you. For example, for the init container, we talk about it here. We tell you a little bit more about it. Same thing for the sidecar and these other ones. Okay, so I wanted to let you know that was there as well. Okay, so that ends the formal presentation. I hope this was useful. If you have any questions, of course, the links to WebAge are there, and we'd be happy to help you out with any questions. The materials that I used, okay, will be available. They can email those out to you as well. And a video was being taken as we were going through the presentation. So if you think this was something that might be useful for some of your coworkers or somebody else that you know, then you can point them up to the WebAge site, and they just have to go to WebAge and put in the word webinar in the search engine there, and they can find their way over to the video of today's presentation. Okay, and with that, I'm going to close it out. Okay, let you get back to your day. Thanks for being here. Thanks for checking out our presentation.